Alright everybody, welcome back. In this video we're going to continue on with section 6.12 of AP Calculus BC, and we're going to finish up our lesson on integrating using linear partial fractions. We've done a couple of examples. We're going to get into a third example right here, and this is going to should be a short video because we're just going to be doing this one lone example in this video. We are going to integrate the integral of x squared plus 3x minus 6 all over x to the third plus 3x squared minus 4x minus 12. So in our denominator we have an x to the third. So with four terms, I'm going to use factoring by grouping in order to break this down. And I don't know how many of you use this method. I know I'm a big fan of it. I've started using what's known as the box method for factoring polynomials like this. I'm going to take my GCF out of my first row and then see what I need to multiply by that to get all the others. And that tells me that I can factor this as x plus 3 times x squared minus 4. And further, I know that x squared minus 4 can be broken down with the difference of squares. And so this is going to be x plus 3, quantity x plus 3 times quantity x plus 2 times quantity x minus 2, which means, I'm going to give myself a little bit of room here now that I have that factorization, which means that I'm going to decompose this expression right here as the integral, and I'm going to put a constant factor over each of these x plus 3. Let me slide up a little bit here. And then b over x plus 2 and c over x minus 2. Alright, so now that means, don't know why I put parentheses around that. My brain's kind of checking in and out here. That means that x squared plus 3x minus 6 has to be equal to. And in order to get each of these fractions over the common denominator, I've got to multiply by all of the other denominators. So for this first fraction, a, I have to multiply this by x plus 2 and x minus 2 in order to get it over the common denominator. And I'm just going to write that as x squared minus 4. For the middle fraction, I need to multiply it times x plus 3 and x minus 2, which when we multiply those together, that's x squared plus x minus 6. And then for the last one, I need to multiply it by x plus 3 and x plus 2, which when I multiply those are x squared plus 5x plus 6. Okay, so multiplying all of these out, we get ax squared minus 4a plus bx squared plus bx minus 6b plus cx squared plus 5cx plus 6c. And then I've got to come up with my system of equations based off of this information. My x squareds have to be equal on both sides of the equation. So that means I need 1x squared to be equal to a plus b plus c. So a plus b plus c has to be equal to 1. Then my x's, there's an x term, there's an x term. So that means that b plus 5c has to be equal to 3. And then lastly, my numbers, which gives me the equation that negative 4a minus 6b plus 6c equals negative 6. Alright, so now I have a system of equations in 3 variables to solve. One of those 3 equations just has b's and c's, so I'm going to combine the other 2 to get rid of the a's. I'm going to go ahead and multiply this one by 4. Gives me 4a plus 4b plus 4c equals 4. We add those 2 together, we get negative 2b plus 10c equals negative 2. And then I'm going to take this equation and multiply it by 2. And I'm going to add these two together. I get 20c equals 4. So c is equal to 1/5. If c is equal to 1/5, that makes this 2b plus 2 equals 6. So 2b equals 4, so b equals 2. And if b equals 2 and c equals 1/5 from this equation up here, then that means that a has to be equal to -6/5. So I have all of my fractions. And so we can rewrite this as the integral of -6/5 over x plus 3 plus 2 over x plus 2 plus 1/5 over x minus 2. And I did this in one of the problems in the last video. I'm going to go ahead and factor a 1/5 out of this, just because I like a whole lot better when my numerators here are whole numbers. And now I'm going to go ahead and integrate. This is -6, natural log of the absolute value of x plus 3, plus 10, natural log of the absolute value of x plus 2, plus 1, natural log of the absolute value of x minus 2, all that plus c. And there's our integral. Ta-da! Alright everybody, that brings us to the end of this video and the end of this lesson. In our next videos, we're going to do some extension that goes beyond what's actually covered in AP Calc BC. We're going to look at some more partial fractions where we have repeating linear factors or irreducible nonlinear factors and how we can deal with those situations. So it's a little bit more difficult than the partial fractions we're doing now, but I really enjoy it. So we'll see you then. All right, everybody, have a good rest of your day and see you next time.